Do you know where the other you is? How about we look for it together? Come on, let's go on a little journey. Part 1: The Origins of the Multiverse Theory. The idea of a multiverse, the possibility that our universe is only one among many, did not emerge suddenly. It evolved through centuries of scientific curiosity, philosophical speculation, and the persistent human desire to understand why reality is the way it is. Early forms of the idea can be traced back to ancient Greek philosophers who debated whether existence might contain countless worlds, each separated by vast cosmic distances. Though these primitive concepts lacked scientific grounding, they reflected a recurring intuition. Perhaps our reality is not unique. The modern foundation of the multiverse began forming in the early 20th century when scientists attempted to explain the structure and evolution of the cosmos. Albert Einstein's general theory of relativity provided a new way to describe space, time, and gravity, revealing that the universe is dynamic rather than static. His equations allowed for multiple possible solutions, different shapes, sizes, and fates for the universe, an early hint that reality might not be singular. In the 1920s, astronomer Edwin Hubble made a discovery that transformed cosmology. Galaxies were moving away from us, and the universe was expanding. This finding led to the Big Bang theory, which proposed that the universe began as an unimaginably dense point. But this raised a question: what existed before the Big Bang, and could the event that created our universe be just one of many cosmic births? In the 1980s, physicist Alan Guth introduced the idea of cosmic inflation, a period of exponential expansion occurring just fractions of a second after the Big Bang. According to this theory, space expanded faster than the speed of light, smoothing out the universe and setting the conditions for galaxies to form. Although inflation explained many observed features of the cosmos, it also pointed to an unexpected conclusion. If inflation could happen once, it could happen repeatedly, generating countless bubble universes with different physical properties. This marked one of the first scientifically grounded proposals that the multiverse might be real. As quantum physics developed, new interpretations of reality emerged. Some scientists suggested that the strange behavior of particles appearing in multiple states at once could imply the existence of parallel outcomes, each unfolding in its own branch of reality. This further strengthened the notion that the universe we see is only a fraction of a much larger structure. By the late 20th and early 21st centuries, the multiverse had become a serious topic in theoretical physics. Ideas from string theory, cosmic inflation, and quantum mechanics converged, each offering its own path to imagining a reality composed of multiple universes. Although these theories differ in their details, they share a common theme. Our universe may be one of many possible worlds, shaped by different laws of physics, different histories, and perhaps even different versions of ourselves. The origins of the multiverse theory reflect the evolution of scientific thought, from philosophical speculation to mathematical models and physical theories. It remains a controversial idea, not yet provable, but impossible to ignore. The possibility that the universe is far larger and more complex than we ever imagined continues to push science to its limits, setting the stage for deeper questions about identity, existence, and the nature of reality itself. Part 2: Quantum Mechanics and the Birth of Infinite Realities. Quantum mechanics reshaped our understanding of the universe by revealing that, at the smallest scales, reality behaves in ways that defy common sense. Unlike classical physics, which predicts precise outcomes, quantum theory describes a world built on probabilities. Particles do not occupy a single location or state until they are measured. Instead, they exist in a superposition of possibilities, each representing a different potential outcome. This strange behavior became a cornerstone of modern physics and opened the door to a radical idea. Every possible outcome might actually occur, but in different branches of reality. In the 1950s, physicist Hugh Everett proposed the many worlds interpretation, a bold attempt to solve the puzzles of quantum mechanics. Everett suggested that the universe does not make a single choice when an event occurs. Instead, it splits into multiple versions, each representing a different result. When a particle chooses one path, another universe forms where it takes the opposite path. This process, according to Everett, happens continuously and automatically. If true, the universe is constantly dividing, generating a vast network of realities where every quantum event unfolds in all possible ways. Quantum entanglement added further intrigue. When two particles become linked, their states remain connected no matter how far apart they travel. A change in one seems to instantly affect the other, a phenomenon Einstein famously called spooky action at a distance. Entanglement suggests that information in the quantum world is woven into a deeper structure, one that may extend beyond the boundaries of our universe. Some theorists propose that entangled systems could be evidence of hidden layers of reality, reinforcing the idea that our cosmos is part of a larger, interconnected framework. Experiments in modern physics continue to reveal quantum behavior that challenges intuition. Studies show that particles can tunnel through barriers, appear in multiple positions, and influence events that have not yet occurred. These findings push scientists to explore interpretations that can accommodate such counterintuitive results. While not all researchers agree on the multiverse explanation, quantum mechanics remains one of the strongest motivations for considering it. The theory's mathematical foundations naturally allow for parallel outcomes, and the many worlds interpretation provides a coherent way to understand them. Quantum mechanics does more than describe tiny particles. It forces us to rethink the nature of existence. If every possible outcome takes place, then reality becomes a complex tapestry of interconnected possibilities. Infinite histories, infinite futures, and infinite versions of individuals may all be encoded in the quantum fabric of existence. This perspective transforms the multiverse from a speculative idea into a potential consequence of the laws that govern the smallest building blocks of nature. As research advances, quantum theory continues to raise profound questions. Are these parallel branches truly separate, or could they influence each other in subtle ways? Could quantum effects provide a path to detecting other universes? Such questions push the limits of scientific imagination and set the stage for exploring how these theoretical realms might contain alternate versions of ourselves. Part 3: Parallel versions of you, how they might exist. The possibility of parallel versions of a single individual arises naturally from theories that predict multiple universes. If reality truly branches into countless variations, then each person may have numerous counterparts living out different outcomes. These counterparts are not clones in a traditional sense, but alternate versions shaped by divergent events, decisions, or even entirely different physical laws. Understanding how these other selves might exist requires examining how multiverse models apply to human identity. In the many worlds interpretation, every quantum event produces a split, creating distinct realities where each possibility unfolds. While most of these events occur at microscopic scales, their cumulative effects eventually reach larger systems, including human lives. A trivial change, like pausing for a moment before crossing a street, can create dramatically different trajectories over time. In one branch, a person might pursue a career in science. In another, the same person might become an artist. These divergences compound, producing a vast landscape of unique identities shaped by chance and circumstance. Some models imagine universes with entirely different initial conditions. In these scenarios, versions of an individual could arise from familiar human processes, yet grow up in worlds unlike the one we know. The environment, culture, and governing laws of physics might vary drastically. A counterpart might be born into a society with advanced technology or in a universe where the fundamental forces operate differently. Even small changes in planetary formation, evolution, or climate could influence how life develops, reshaping personalities, talents, and opportunities. Other frameworks propose universes with completely different histories. In these, a version of you might never come into existence at all. Perhaps your parents never met, or a crucial ancestor lived a different life. Conversely, you might exist, but with a different name, upbringing, or genetic makeup. These possibilities highlight that other yous do not necessarily resemble the person you are now. They can be drastically different individuals, connected only by a shared origin in the broader structure of reality. These interpretations challenge our assumptions about selfhood. If multiple versions of a person can exist, what defines individuality? Is someone still you if their memories, experiences, and personality have evolved along a different path? The concept of parallel selves forces a reconsideration of identity as something fluid, shaped by countless external influences rather than a fixed essence. Each variation represents a different response to a changing environment, a reflection of the endless possibilities embedded in the fabric of existence. The idea of alternate versions of oneself is both fascinating and unsettling. It raises questions about choice, responsibility, and destiny. Do these counterparts make us more or less significant? Do their successes and failures matter to us? While science has not confirmed the existence of such parallel individuals, the theories suggesting them remain influential. They encourage deeper reflections on how fragile and extraordinary each personal timeline truly is. As the multiverse concept continues to evolve, the study of these hypothetical counterparts becomes more than abstract speculation. It becomes a lens for examining the nature of consciousness, individuality, and the profound impact of every decision. These considerations prepare the ground for exploring how small changes can shape entire histories, a theme central to understanding the larger multiverse landscape. Part 4: Alternate Histories: How Small Choices Create New Universes. The concept of alternate histories emerges naturally from theories suggesting that reality branches whenever multiple outcomes are possible. According to these ideas, every decision, no matter how insignificant it seems, can generate a new path. Each path leads to a distinct timeline with its own sequence of events. These variations accumulate, forming a vast network of realities shaped by the choices of individuals, societies, and even natural processes. At the core of this idea is the recognition that life is extraordinarily sensitive to initial conditions. A single moment can redirect the future in profound ways. Consider a simple example: missing a bus. In one timeline, a person arrives early and catches it, leading to a predictable morning. In another, they miss it, encounter someone new, or make a decision that alters the course of their life. Over years, these tiny divergences build entirely different narratives, new friendships, different opportunities, or unexpected challenges. This phenomenon is not limited to individual lives. Entire civilizations could follow alternate paths based on small triggers. A scientific breakthrough might be delayed, a political leader might make a different choice, or a natural event might unfold slightly earlier or later. Each outcome reshapes the cultural, technological, and social landscape. The result is an immense collection of possible worlds, each carrying its own version of history. On a broader scale, some theories suggest that the universe itself is governed by probability. Cosmic events, from the formation of galaxies to the evolution of species, are influenced by countless random factors. A slight variation in temperature after the Big Bang might lead to stars forming at different rates. A tiny mutation in an ancient organism might prevent or accelerate the development of intelligence. These events, though microscopic in origin, can ultimately produce universes with entirely different ecosystems, species, or levels of complexity. The idea of alternate histories invites a deeper examination of time. Instead of a single line extending from past to future, time becomes a branching structure where every possibility unfolds somewhere. This model transforms history from a fixed sequence into a dynamic web of interconnected timelines. Each universe follows its own internal logic, shaped by the outcomes that define its particular version of reality. This perspective also influences how we think about fate. If countless timelines exist, each containing different possibilities, then destiny becomes a flexible concept. A person might experience success in one universe and failure in another. Relationships might form in some worlds and never happen in others. The presence of alternate histories suggests that outcomes are not predetermined, but emerge from a delicate interplay between chance and choice. Understanding this concept also provides a unique lens for exploring human potential. If alternate versions of events unfold across separate realities, then the range of what could happen expands dramatically. Every missed opportunity, every unspoken decision, every imagined possibility may exist somewhere. This reinforces the idea that life is a collection of fragile, branching moments that continuously shape the world. Although alternate histories remain theoretical, they offer a powerful framework for imagining how the multiverse might function. They highlight the importance of small actions and remind us that reality is not as rigid as it appears. These ideas set the stage for examining the scientific efforts to understand whether such branching timelines leave any trace, and how competing theories attempt to explain the structure of the multiverse. Part 5: Scientific Evidence and Competing Theories. The multiverse remains a theoretical concept, yet several areas of modern science provide hints that such a structure might be possible. While no direct proof exists, multiple fields, cosmology, quantum physics, and string theory offer frameworks that naturally produce more than one universe. These proposals aim to explain observations that cannot be fully addressed by a single universe model, driving scientists to consider broader possibilities. Cosmic inflation is one of the strongest foundations for multiverse speculation. This theory, developed to explain the uniformity and large-scale structure of the cosmos, suggests that space expanded at an extraordinary rate shortly after the Big Bang. According to some versions of the model, inflation does not end everywhere simultaneously. Instead, regions of space stop expanding at different moments, forming isolated bubbles with their own physical conditions. Each bubble functions as a separate universe, cut off from the others by rapidly expanding space. Although we cannot observe these neighboring regions, mathematical models indicate that they could exist beyond our cosmic horizon. Another source of multiverse implications comes from the fine-tuning problem. The physical constants that govern our universe, such as the strength of gravity or the charge of electrons, seem precisely calibrated to allow the formation of stars, planets, and life. Even slight deviations would render the universe hostile or completely inert. Some scientists argue that this apparent precision is easier to explain if countless universes exist, each with different parameters. In such a scenario, we find ourselves in a universe that supports life simply because only universes with suitable conditions can develop observers. Quantum mechanics also contributes to the conversation. Although the many worlds interpretation remains controversial, it provides a coherent explanation for the probabilistic nature of quantum events. While this model does not claim to offer proof, it presents a mathematically consistent picture of branching realities. Critics argue that the theory is untestable, while supporters maintain that its elegance and internal logic make it a viable explanation. The debate reflects the broader challenge of reconciling quantum theory with larger scale physics. String theory adds another dimension to the discussion. It proposes that particles are not point-like objects, but tiny vibrating strings, each mode of vibration corresponding to a different particle. To function, the theory requires extraspatial dimensions beyond those we experience. Some versions predict a landscape of possible universes, each shaped by different ways these dimensions can be compacted. This framework produces an enormous number of potential realities, each with its own physical laws. Although string theory has not been experimentally confirmed, it remains one of the most ambitious attempts to unify fundamental forces. Despite these promising ideas, skepticism remains strong. Critics point out that a theory predicting other universes is difficult to test, since those universes would lie beyond direct observation. Science traditionally relies on measurable evidence, and the multiverse currently stretches that boundary. Some researchers argue that the concept risks drifting into philosophy, while others believe that indirect clues, such as patterns in cosmic radiation or subtle signatures left by collisions between universes, may eventually provide support. The scientific landscape, therefore, is divided. Some theories naturally generate multiple universes, while others remain firmly rooted in a single cosmos view. The debate is driven by the desire to understand why the universe exists in its current form and whether deeper structures lie beneath observable reality. Although no consensus has been reached, the exploration of competing ideas keeps the multiverse question alive, pushing science toward new methods, new instruments, and new perspectives on the nature of existence. This ongoing discussion prepares the way for a final topic: what these ideas mean for identity, destiny, and our understanding of reality itself. Part 6. What parallel universes mean for identity, fate, and reality. The possibility of parallel universes forces a reconsideration of some of the most fundamental questions humans have ever asked. If countless realities exist, each containing different outcomes and alternate versions of events, then concepts like identity, destiny, and truth become more complex. The multiverse model suggests that existence is not a single story, but an immense collection of interconnected narratives, each offering a different expression of what could be. Identity, for example, becomes a layered concept rather than a fixed one. If multiple versions of a person exist across various universes, then individuality is shaped not only by personal experiences, but by the specific timeline in which those experiences unfold. A counterpart raised in a different environment, shaped by a different set of influences, or exposed to different opportunities, may evolve into a radically different individual. These variations highlight that identity is not an unchangeable essence, but a dynamic process influenced by circumstance, choice, and chance. The idea of self becomes a spectrum rather than a single point. Fate is also transformed under the lens of the multiverse. In a single universe model, destiny might seem like a path shaped by necessity or predetermined factors. However, if countless versions of events exist, then no single outcome holds absolute authority. A person might face success in one universe and struggle in another. Relationships may form in one timeline and never occur in a different branch. This framework suggests that destiny is not a rigid structure, but one of many potential trajectories shaped by decisions and external forces. The presence of alternate realities challenges traditional notions of inevitability. Reality itself becomes more difficult to define. In everyday life, individuals assume that the world they experience is the complete structure of existence. Yet the multiverse idea implies that observable reality is only a tiny fraction of a much larger system. Each universe may operate with its own rules, principles, and histories. Some may resemble ours closely, while others diverge dramatically. This raises profound questions about the nature of truth. Is reality defined by what can be perceived, or does it include realms beyond human observation? If unobservable universes exist, does that diminish the significance of the one we inhabit, or does it enhance its uniqueness? The multiverse idea also reshapes philosophical discussions about possibility. If every scenario that could happen actually does happen somewhere, then the distinction between imagination and reality begins to blur. Choices one never made may unfold in other universes. Dreams, fears, and alternate versions of events may all be realized in different branches of existence. This perspective encourages a deeper appreciation for the current timeline, emphasizing the extraordinary chain of events that define each person's life. Ethical questions also arise. If versions of individuals exist in other universes, should their experiences matter to us? Do their actions carry moral weight, or are these counterparts entirely separate, with lives disconnected from our own? Many philosophers argue that even if alternate selves exist, they do not diminish the meaning of the choices made in this universe. Each timeline remains significant to the people experiencing it. The multiverse concept ultimately expands the boundaries of human thought. It invites exploration into questions that reach beyond empirical science, touching on philosophy, psychology, and the nature of consciousness. It challenges assumptions about the world, suggesting that existence may be far richer and more intricate than previously imagined. While the multiverse remains unconfirmed, its implications inspire curiosity and push the imagination toward uncharted territory. In the end, the idea of parallel universes serves as a reminder of how mysterious reality remains. Whether or not these realms exist, contemplating them deepens our understanding of what it means to live, choose, and exist in a universe that is vast, fragile, and full of possibility. Thank you for joining this journey through the multiverse. Keep wondering, keep exploring, and remember, somewhere out there, another you might be making a different choice. Until next time, stay curious and embrace the mysteries of reality.